So as we continue looking at surface area, let's talk about the shape of a cylinder again. So a cylinder, if we think of like a can, has a top base and a bottom base, which are circular. And then we have this one, what we call it like a lateral face that kind of wraps around the can. So it's this kind of this curved face that goes around the can itself. So the surface area includes all three parts of that. Okay, so let's look at this from the geo area of things. Let's see if I can get this to maximize a little bit. So if we have a can, notice how there's the top base and the bottom base, and then we have this that wraps around the two bases. So if I unfold this, notice that to find surface area, we actually have three surfaces that we have to calculate. So we have a circle, and then this right here. So if we put this back together, we kind of start to pick up on that from the center out to here is going to be a radius. So we know how to find this area of a circle. That's going to be pi r squared. So pi r squared is going to give me the area of the top, which means there's also going to be the area of the bottom. So we're going to have this pi r squared twice. Now notice that a cylinder has a height. So that has to be given to us as well. But notice how this distance around, if we unfold it again, notice as we unfold it, what we're seeing is this wraparound is wrapped around the edge of the circle. So if it's wrapping around the edge of the circle, that means that's the distance around a circle. So what that's kind of telling us is this distance here actually wrapped around the circle. So this has got to be the circumference of a circle. Well, the circumference of a circle is 2 pi r is, since we were given the radius, 2 times the 3.14 times the radius, if you will. We have that kind of going on here on this example. So if I scroll on down here, I think there's some examples here, something. So if we look at an example of a circle, calculating the surface area of a circle, let's see if I can get all this other junk out of the way. Okay, so for me, so how to calculate the surface area of a circle? Well, they didn't give us really a hard problem. So it looks like they said the radius is 1. It looks like they're saying the height is 3. So if we unfold this, so they're saying the radius is 1 and the height is 3. So keep in mind that if we want to find the area of the circle, so this is going to be area equals this pi r squared. And notice how if we use 3.14 pi, so that's going to be 3.14 times 1 squared. But notice how we're going to have two of those. So really, we're going to have to do this twice. So you're going to have this area equals this 3.14 times 1 squared again. But then to find this other area, this third area is going to be the height and the circumference. So if I multiply 2 pi r times the height, that's going to give me the area of this rectangle here. Because remember, this wrapped around the actual can, so this distance around doesn't have to be given to us as long as we know the radius of the circle and the height. So if I substitute into that, we get a third area, which is going to be 2 times this 3.14 times the radius, which they said was 1, times the height, which they said is 3. So all we have to do is substitute into formulas, and that will give us the area. So let me erase my math here, and let's just see what they do here. So let me kind of should have paused my video here, but I about got it. So what they say do is if I click on these sections and get my stuff out of the way so I can read it. So notice how the area of a circle is pi r squared. The circle is pi r squared. And then notice how the area of this is going to be, notice that this distance here is going to be the circumference. So it's going to be 2 pi r times the height. So if we add all three of these areas together, notice how this gives us a formula actually. Since we have a pi r squared plus a pi r squared, that's going to be 2 pi r squared. That's going to be area of the bottom base and the bottom base. And then the area of this rectangle here, which wrapped around the can, is defined by the circumference, which is 2 pi r times the height. So if we combine all three of these areas together, we get what's called the surface area formula, which looks like this. So if I go ahead and replace the variables, so if I click on this here, it'll substitute the 1 in for the radius, substitute the 3 in. Notice how there's not a whole lot of substitution in because pi is already known as 3.14. So all we really got to do is substitute the radius in and the height in into the correct spots in the formula. And like I said, we can use a calculator. And notice how here it keeps the pi in the problem until the very end. So it doesn't convert over until at the very end. Then you can multiply by 8 times 3.14 and get the answer. Or if they don't ask you to change pi to 3.14, you can use this to represent the area, the surface area of that can, that cylinder. So keep that in mind. To find the surface area of our can, we have our cylinder. It's going to be this formula here. At this time, we're not going to talk about volume just yet. So notice that the height is the distance from the top and the bottom. Notice how it can be given inside the cylinder, or it's also this edge out here. So the height is just the distance from the top of the can or the cylinder to the bottom. And notice how the radius is the distance from the center of the base out, or this from the center of the top out. So if we know those two dimensions, and like I said, if we know the area of a circle, we're halfway there. The other part gets a little trickier because 2 pi r represents this rectangular, if we unfolded it, it's that rectangular edge, and then the height represents the other edge of that rectangle if we unfolded it out. So that's how we can find the area of the surface area of a cylinder. So we'll pause here and we'll talk about a sphere in the next video.